Microlens event Macho 96 BLG5, aka we see so many thousands of these for a year we haven't even bothered trying to name them anymore, demonstrates a really neat effect observed over a period of 7 months. This is one galaxy here in the telescope image taken on April 28, 1996. See the galaxy? See it? See it? Right there? No? Oh yeah, alright. Granted, it's really blurry, but it's clear there's only one of it. And there it is again in November. Brighter, clearer, but it is one galaxy. We've been staring at this part of the sky for decades. It's one galaxy. We know it's one galaxy. It acts like one galaxy. It emits like one galaxy. There's absolutely no question it is one galaxy. Except in the July photo. In the July photo, all of a sudden, clear as day, there is not one, but 2 galaxies. There's no question it emits like one galaxy, it acts like one galaxy, and by November again it looks like one galaxy again. But in the meantime, we are seeing double. What event in our life causes us to see double? Is also responsible for things going in and out of focus like nobody's business. Where in your life do you sit with things going in and out of focus until you're seeing double, until something goes click and you're seeing single again? The answer is the chair in your optometrist's office when different lenses are being slatted in front of your eyes to see whether you need a new prescription for your contacts or not. If you're not in the optometrist's chair and you are seeing double, drop everything. Do not pass go. Do not collect $200. Go to your doctor's office and to your optometrist's office and get exam, not just of your eyes, but your entire head. Something is causing you to see double, and the only way it does that is by messing with the shape of the lens in your eye. And if something is inside your head pushing on your eye, you want to know right now whether it is a tumor and whether that tumor, if it exists, is benign or not. Seeing blurry can be corrected by a better pair of glasses, but seeing double is a harbinger of an immediate medical problem. Be that as it may, we are looking through a telescope, and we are totally on top of the lens on that telescope. It's not a problem with the telescope lens. So what is it that's causing outer space to act as if a giant pair of new glasses has drifted across our vision? The answer is a black hole. Check out what light does when it enters the region of warped space near a black hole. The space bends, so the light bends too. It bends the same way that lenses bend light. See the way that light bends around something? If you're right here, lucky doggy that you are, you're at the focus point, and everything that enters your eyes right here will be in razor sharp, crystal clear focus. If you're out here, instead of 1 point of light, you'll have 5 points of light. Everything will be fivefold, and it'll be very blurry and hard to focus on. But one way or another, you can still see things happening over here, but at a different kind of focus than you would have without that giant lens in between you and it. Scientists here on Earth can track black holes through space by looking for what appears to be a giant invisible lens floating through space. Invisible because, hey, with the light going into orbit around it, we can't see it, but lens bending the light that doesn't go into orbit. This is what a lens would do. This is what a very large mass would do. Instead of the light going straight, the light bends. We can replicate that bend perfectly with lens equations, magnification, focal length, and everything else to make the exact same pattern. Really? Absolutely. Check it out. We're looking at the image of a distant galaxy, a perfectly ordinary galaxy, far, far away, on a clear night through a good telescope, with a large mass in the way. Do you see the large mass? It's red. Do you see it? No? I bet you'll see it if we make it a little bigger, and a little bigger still, and a little bigger still, and a little bigger still. Oh my God, it's eating the galaxy! No, it's not. The galaxy is perfectly fine. The galaxy is far, far away, and I'll grant you that with the amount of time that light takes to get here, it's even long, long ago. But nothing's happening to the galaxy. The light that reaches our eyes is making a detour before it gets here. Now, if I call somebody over and say, see the black hole? Now you're seeing the black hole. You're also seeing double. See the way the light ends up in two different places depending on where it starts? That is what gravitational lensing looks like. Oh yeah? Oh yeah? Well, if mass warps space and distorts time, and everything, including light, travels in weird curved paths whenever there's any mass around at all, well, why don't we see light bending around other masses, What about the sun? That's pretty big. What about our planet, Well, big, but not big enough. We only ever see gravitational lensing around black holes. There is because they're the only things that are big enough for the gravitational lensing to be visible to the human eye. Yes, we do get gravitational lensing, and light does bend around pulsars and other exceptionally large outer space bodies. In conclusion, I hope we've put to rest a lot of the popular myths surrounding black holes. They're not black. We don't know what color they are at all. In fact, for all they know, they might be pink with orange flowers and birds and clouds and whole civilizations in there doing great works of art. It's just that we can't see them because the light is going into orbit or crashing on the surface rather than reaching our eyes. All right, probably not with the orange flowers and the whole civilizations, because what they really are supermassive cores of dead stars and dead galaxies, and whatever's down there is probably pretty dense. Black holes are not giant vacuum cleaners. They don't suck in unwary passers-by. They act the same way as other masses. If you get close enough, you go into orbit. If you get too close, you crash on the surface. Although you can't see a black hole by definition because the light never reaches your eyes, you can certainly see the huge accretion disk of all the mass in the neighborhood, which is happily orbiting the biggest mass in town, namely the black hole. You can record the bipolar jets of X-rays, gamma rays, dust, rocks, and space schmutz being ejected in the very end of the reaction that brought the star to its end. They can also be observed from distances far too far away to notice the accretion disk and the bipolar jets by looking for the characteristic pattern of gravitational lensing, seeing double, seeing blurry, into and out of focus, or that wonderful spiral effect that makes it look like somebody's photoshopped your night sky. Once we know what to look for, we'll find them all over the far reaches of space, and the biggest and best one in the neighborhood right in the center of the Milky Way galaxy.